Welcome to Air Quality Matters, and this is a conversation with Cath Noakes. Professor Catherine Noakes is a chartered mechanical engineer with a background in fluid dynamics. She is the Pro-Dean for Research and Innovation for the Faculty of Engineering and Physical Sciences at the University of Leeds, where she leads research into ventilation, indoor air quality and infection control in the built environment using experimental and modelling-based studies. From April 2020 to 22, she was a participant in the UK Scientific Advisory Group for Emergencies, SAGE, where she co-chaired the Environment and Modelling Group sub-focusing on the science underpinning environmental transmission of COVID-19. She has also contributed to numerous advisory and working groups, including the WHO, and as part of the working group for the Royal Academy of Engineering work on infection-resilient environments. In 2021, she was awarded an OBE for her contribution to the COVID-19 pandemic response, and in 2023, she was awarded the Royal Society Gabor Medal for her contribution to interdisciplinary science in understanding transmission of infection. We discussed, as you'd imagine, her work in the last few years and what the built environment can take away from this global pandemic. We talked about risk, air cleaners, and her experience as a domain expert suddenly thrust into the whirlwind that was this global pandemic. Cath is such a down-to-earth, easygoing person to talk to. I always enjoy our conversations, and this was no exception. As always, thanks for listening. This is a conversation with Cath Noakes. So what do you think has been the biggest takeaway then for the built environment from this pandemic, Cath?
I think it's had a really massive impact in perhaps both positive and some less positive ways. So I think on the more positive side, it has massively catapulted indoor air quality and ventilation up the agenda. You know, I don't think I've ever seen so many people talk about ventilation. We saw it in the national press. We saw it in conversations worldwide. It made its way into scientific communities all across the world, people who've never thought about ventilation before. And that made it to some of the highest levels. I mean, there was a point where the Prime Minister said ventilation. I wasn't very proud of much during the pandemic, but take your little wins.
Yeah.
And I think that has, it's taken something that was already a growing topic, particularly indoor air quality, but it's taken it to it's just accelerated the conversations, and it's got many more people in there. Before this, I was one of these weird people who worked on some niche thing around airborne infection, and now suddenly it's now mainstream. So I think that's massive positive. I think the bit which is perhaps more of a challenge than a negative is I think it's exposed just how much we don't know. It's suddenly got us thinking about buildings and their ventilation. There are people in quite senior levels who say, well, how many buildings in the UK have good ventilation? And my answer was, I really do not know. It really got us recognising that we know very little about the vast majority of buildings. There are studies on certain sectors. There's probably a little bit more on housing, possibly a little bit more on schools. There are whole sectors where there's almost no knowledge whatsoever, nothing published. And even what is there is really patchy. And then you also realise there's vast numbers of buildings that don't have a properly designed ventilation strategy in any way, shape or form. And so, yes, we have building regulations, we have standards, we have guidance and things, but that's just, there's huge numbers that just don't even touch on it. We don't have any form of ways of doing compliance or enforcement. So I think it really brought all of that out in the open as well, and made us start to think about buildings as part of, we talk about sustainability. In some respects, we talk about safety, but we've not really talked about healthy buildings properly in an open conversation outside of a sort of subset of scientific communities. And I guess the third thing I think it has done is brought different scientific communities together to talk about this. So there always have been people who've worked in these areas. I think some of them have, in some respects, those people have always collaborated reasonably well. But I think it's taken those people into bigger conversations, and I think it's taken, it's enabled conversations beyond the sort of the core physics, building science, aerosol science piece around ventilation and pollutants to really start to think about, the social side of that, the behavioural aspects, the economic piece, and the complexities of it all. We can try and pretend ventilation's simple. So some respects, yes, can be, but it's actually not very simple. The physics of it's very complicated, and it's massively influenced by what people do in their buildings.
I landed a rather unfair question on Francesca Brady, who kind of manages Air Rated. It's an air quality standard, if you like, for the workplace predominantly. And I asked her the question, like, if you were writing the script for the development of air quality awareness, notwithstanding that nobody wants a global pandemic, would the pandemic have been in there for the recognition of air quality or not on the whole? And her response was probably not, because she felt that it was ultimately more of a distraction in the end, that it sent people off down rabbit holes and down dead ends that were often unhelpful. And we were starting to build up a narrative of healthy workplaces and the business case for air quality. So it was a question I was keen to ask you the same. Writing the script of the last, but if you're in 2019 writing the script for the next 3 or 4 years, just from an air quality perspective, again, I say nobody wants a global pandemic. Would it have included COVID for awareness, or do you think on balance it's been more harmful than of benefit?
So actually, I think it would have been in my script, and I say that I suppose because I'm somebody who's always worked on airborne infection. That's been my focus area. So I guess it would have been, and even to the point that I remember putting in a grant application in 2008 and going to the interview for this, and my pitch was, imagine a global pandemic sort of thing for why we need better ventilation in buildings. And that was for hospitals more than public buildings. But, yes, I think it was in there. In terms of the harm versus good, I think you're right. There were some rabbit holes, and I think one of the biggest ones that we could have spotted a bit sooner is explaining ventilation better to people, because we encouraged people to ventilate, and for the vast majority, particularly at home, the only thing they could do was opening a window. And as we know, ventilation through opening a window in some circumstances can be incredibly effective. It can be the most effective thing you can possibly do. In other circumstances, it can be completely useless and it barely does anything. And I think, on balance, opening your windows was going to usually be a good thing to do. But we know that it doesn't work in the winter. We know it doesn't work in poor weather conditions. We know that certain flow thermal conditions, it just doesn't work. And I think what we've inadvertently done in part of that is create a bit of a narrative that says ventilation equals a window, and actually it doesn't at all. And to be honest, the best ventilated buildings usually have a mechanical ventilation system of some description, because we know that that's reliable, it's consistent, etc. And a well-designed mechanical ventilation system, for the most part, is probably going to do a better job. I think the other challenge around air quality is, of course, the pandemic focused very much on an indoor source of microorganisms from people, but it didn't really think about the bigger picture of air quality. And when we're talking about indoor air in buildings, we have to think about all of those sources. We have to think about the indoor sources. We also have to think about the outdoor sources. And there will be trade-offs. Unless you've got endless money, it is very challenging to create a perfect environment, and especially if we're talking about retrofitting existing properties. And with the best will in the world, however much we know that schools need better ventilation, hospitals need better ventilation, lots of workplaces do, people do not have the money to invest in those things. So we will have to figure out ways in which to get balances in there, and that balance won't be perfect. But we do have to think about when it's appropriate to shut the windows because of your outdoor sources, when it's appropriate to deal with the indoor sources, when actually ventilation is not your solution. You should be thinking much more about source control and things. And thinking about that bigger, wider range of pollutants. And again, I think it's helped that conversation. I'm delighted that, for example, our Chief Medical Officer in 2022 wrote his annual report on air quality and included a massive section on indoor air. And we were very privileged to be asked to write some of that. And we were asked to focus on solutions. So we got some of the engineering pieces in there, which often are missing from the more health-facing type documents.
The second note I made when you started there was about what we don't know. And it made me think that one of the things that an acute event causes, an emergency causes, is that we're forced to take a position on something. One of the downfalls of air quality, if you like, is this long-term esoteric problem that we can ignore. It's invisible. It possibly has some impact on us later, but whatever. Whereas the pandemic forced us to take a position not only on risk, how risky is this? How much do we need to worry about this in this particular circumstance? But it forces us to take a position on everything else as well. How good is the ventilation in our assets? How do we fix that? What would a roadmap look like? What is the cost-benefit analysis of going that? So it forced everybody to take a magnifying glass to the whole process, including how do we communicate this better? It's the first time ever governments have had to communicate at a big scale on air quality. Well, I guess since the smogs in London or something. But so I think that's been the really interesting transition, is it's not that we don't know a lot of stuff. It's we've never been forced to take a position on any of it. It's always been academic, further research required type positions. It's never been, right, okay, Cath, I'm holding a gun to your head. Yes or no? What's the solution here? That's an uncomfortable place to be, isn't it, in that world?
It is. And I think we have to be really careful that we don't end up in the political world of living by sound bites and trying to simplify everything, because there are some fairly straightforward messages that we should be giving around ventilation and indoor air quality, and absolutely education is a massive part of this. Education for the public, education for professionals, education for policymakers, understanding the mechanisms that we can use to reduce sources, the mechanisms we can use to improve ventilation and things. But we also have to, and we have to find a way of balancing that sort of simple messaging with recognising the complexities and uncertainties in it. There is no one size fits all solution. Every building is different. The solution for every building is going to be different. And just because a technology works well in one place doesn't mean it will necessarily translate and work well in another place. And I think, you sort of touched on better go and do some more research. I think we still do need to. Now, maybe that's because I'm biased as an academic, that we always want to do some more research. But I think that research, we do have a lot of knowledge, so we need to build on it. And I think there's some very practical, real world understanding that we need to really understand how, when solutions are implemented, does that do they work in practice? If they don't work in practice, what limits them working in practice? And I think, traditionally, research funding in an academic context focuses quite a lot on novel science. Actually here it's much more about implementation and demonstration. And I think interesting what we have seen, and I don't know if this is worldwide, but certainly in the UK, there is a move for some of the funders to be looking more holistically at this. And I think that's a really good move. So there are grant calls. I mean, there's a grant call out at the moment that we're responding to around health impacts of net zero in buildings. And that's a really good opportunity to explore the practical aspects of it rather than thinking about, can we develop fundamental new novel technologies? It's about how you look at sort of perhaps a whole systems type approach and think through, well, if we put, net zero and retrofits into buildings, how does that have knock-on effects around health? How does that have a knock-on effects around societal behaviours, etc.? So I think there is some really good shifts here. And I mean, one of the really nice things to see is that the community of people who are working in this space, which has grown, are very open to working together across a huge range of different discipline areas to try and tackle some of these things, and working, I think, increasingly more collaboratively with, policy partners and practitioners as well, to enable this to have, to research. There are research gaps and we need to answer some of them, but to enable those to have a real practical impact on things.
And that, I suppose, again, was another thing about an emergency, is it's not just about knowledge, it's about implementation and outcomes. This is being done to create a benefit. And that's one of the advantages of this kind of new multidisciplinary era, really, is that I think COVID probably smashed a lot of those silos up out of necessity, that you couldn't just have knowledge without understanding how supply chains or practitioners were going to implement it in a way that was going to be effective. All of that stuff had to come together, didn't it? Very, very quickly. Do we think those doors are going to stay open? Is your sense now that this collaboration that we saw during the pandemic has held to some degree, or have you started to see people
to some degree
creeping off?
I think the things that happened during the height of the pandemic have obviously dropped slightly, because I mean, it's inevitable that the emergency challenges have dropped off. That doesn't mean the disease has gone away. It's still there, and they're still posing huge issues in hospitals and in work absence and long-term sick, etc. But the sort of emergency side has dropped off. I think where this is perhaps going to become more on a sustainable footing is that bigger picture piece, because I think it's not just the pandemic that's made people realise about indoor air. There's obviously the very sad case of Awa Bishak in Rochdale, who died of mould and flats. We see increasing awareness about indoor air quality and its impacts on health, and I think better evidence. One of the real challenges with evidence is we can say, oh yes, we've measured stuff and it's at high level, or it's not very good, or your ventilation's poor, but actually evidencing that leads to health impacts is a really hard challenge, and we need that evidence, because without that it's very hard to change policy. But that evidence is starting to appear now, I think, and I think it has sort of catalysed groups of people to work on some of those issues. And I think, it's quite interesting to see that, huge numbers of papers and things published during the pandemic, some of which I probably will never read, others which are fantastic. And I think it allowed us to really advance some of our knowledge, particularly thinking about how respiratory particles move in an environment, how you can then use that to calculate risks, how you can use it to explore the uncertainties in that and the variabilities in that. and also recognizing in there that, ventilation, the indoor air was only one part of the mitigations. You can have fantastic ventilation, but if you're a meter away from somebody and you're having a long protracted conversation with each other, frankly, the ventilation's not going to be your answer there in terms of transmission. So it was about us understanding all those real complexities. And it's hard to communicate all that. It's hard to understand all that. But I think, I really do hope that some of that learning is still there. I think the other thing it's opened up is some big international conversations around things like standards for buildings, in terms of ventilation standards, including indoor air quality standards, that recognition that, well, basically we have very little in the way of indoor air quality standards, and what we do have is usually very specific to certain industries or very hard to implement. But even things like ventilation standards, we can see that there's been conversations around the world about, well, what should that standard look like? What's the right, personally, I think that we should be figuring out how we comply with the current standard before we worry too much about should this be a higher number. But I do think it's an important conversation, because that conversation allows us to set where best practice goes. And if you can improve on best practice, then it moves everything with it.
Yeah, and I think standards are both separate to the conversation of quality and outcomes, but also inherently linked. And I think they both have to work away in parallel and in joint venture. You're absolutely right. We know a lot of our problems would be solved if we just met the standards we already have. However, that shouldn't slow the progress of standards like 241, for example, that pushes the boundary conditions of some of those standards and says, right, okay, we need to start thinking about a different way in building. Modalities of buildings in certain conditions need to change. So I think both are really important. It's that smashing together of communities, I think, has been the real positive outcome for me, that we're having conversations with people that we've never had conversations with before. Yes. And you suddenly see things through a different lens. I mean, everybody now has a bioaerosol lens they never had before.
Absolutely.
That strange lady that turned up at the conferences and talked about germs all of a sudden has a new level of authority, in these conversations. It's amazing how that has shifted. The big thing for me, was one of the things I wanted to chat to you about, was the perspective of risk. For the first time ever in this uncertainty, we had to take a position on things. And one of the areas that seemed to be, or one of the disciplines that seemed to be able to cope with that best, was the occupational health, the occupational hygienists, the people that have understood how to handle risk for years and frame it and talk about it in a way and make decisions with the everything that comes with the uncertainty of risk, people's tolerance of risk, people's perception of risk, how it changes over time. They were enormously well equipped during the pandemic, I found, to navigate this. Did you find the same, that all of a sudden hierarchies of control became a thing?
Where I never thought I'd be quite so excited about risk assessment, but yes, you're right. I think that did come in, and hierarchies of control is imperfect for respiratory disease because it is designed more for a chemical hazard or something. But as a starting point on a framework to get us thinking about the fact there are different levels. So yes, if you stay at home, you've pretty much eliminated the risk. But that's largely not practical most of the time, except we're in the most dire bits of an emergency. So how do you do those different levels of risk analysis? And I agree. I think that was a really good framing. And I think, people like, British Occupational Hygiene Society, they played a huge part in helping those conversations, and particularly helping businesses explore how to manage risk, how to put in mitigations, recognizing that you need layers of mitigations. You can't just do one thing. You have to think about different, the Swiss cheese model piece. And I think when we go back to talking about communities and disciplines, I do think the sort of ventilation and indoor air communities have not quite fully connected with the occupational hygiene communities yet. I think those communities are closer together now. There've always been an overlap, but I think that overlap is bigger. But I think there's probably still more we can learn from each other's perspectives on that. And yeah, risk, I think, is a really important thing to think about. It's you know, at some point you have to have what's the tolerable risk, and that tolerable risk is going to be different for different people. And recognizing that, having that conversation about how you manage that and what does that look like in different settings. When are we willing to take more risk? When are we willing to take less risk? That all those conversations happen. I think from my also research perspective, there is something about the quantitative aspects around risk, because we did quite a lot of research. We were quite lucky. We had a number of projects during the pandemic and actually before, which were looking at some of these things. And so trying to we use something called quantitative microbial risk assessment, which is a bit of a mouthful of a tool, but it's a way of actually taking sort of the physics and the biological aspects and wrapping them up together and thinking, well, what might that look like in terms of somebody's exposure and somebody's chances of infection? And it really starts you thinking about, it's very easy to say, oh, well, ventilation is always the answer, but it might not be. So, for example, if you're on a bus, we tend to, oh, the windows aren't open, it must be really bad. But if you're only on that bus for a few minutes, 10 minutes or so, your biggest risk is actually sitting next to somebody who's infected. Whereas if you're sharing a classroom or an office or even a train or something for several hours, then your risks start to go up from an airborne perspective. So thinking about what might be the relative, the most important mitigations in different settings in terms of people's exposures and how that works out is really important. And I think there's also interesting things there about how this plays out with different diseases. So if we look, for example, at COVID, COVID was incredibly hard. Well, the virus that causes it, SARS-CoV-2, was really hard to sample from the environment. It was very rarely found, and when it tended to be in hospitals where there are high numbers of patients. We got better at sampling through the pandemic because those techniques improved, the culture techniques, the methodologies, etc., all improved. But we found really quite small amounts of it compared to, say, other things like flu or whatever. But clearly it was incredibly transmissible. So that really starts to tell you that you need very small amounts of it to become infected. As a sort of contrast, there are some other diseases where maybe you can sample an environment and you can find huge amounts of it, yet you see very little transmission, which perhaps tells you that you need a lot more to become infected. Yeah. So even though you might find it in the air, it might not pose anywhere near the same risks because you just don't inhale enough to become infected. And I think we don't fully understand all of that yet. There's a lot of work still to do there around understanding the exposures and the actual infectious doses or dose response, should I say, for how these different pathogens work and how our environment changes that. And of course, remember, for biological stuff, it is biological. It doesn't survive forever. So that infectivity drops off, and that infectivity is affected by the environmental conditions as well. So there's this whole massive interconnected set of things that determine risk, which we have some of the tools now to calculate, but we have still got a lot of gaps in data to actually put some numbers to it that we would be really confident over.
I'll probably butcher Ben Jones's comment, but it was something like, we can with 100% certainty say now that your chances of catching COVID according to our models are somewhere between 0 and 100%. And it was in jest, but I think the interesting thing about COVID was that it tangibly demonstrated the complexity of risk to people, because they could, in plain English, understand all of these confounding factors, that some people were more susceptible than others, some people were in a space longer than others, some people would receive more of a dose than others. You might have one kid in a classroom that's infected, you might have 8. Your classroom might be big or small, might have good ventilation, bad ventilation, and it goes on and on and on and on. Like the complexity of understanding an outcome is really hard in air
It is.
quality.
And I think one of the things that made it even harder for COVID was that we know that super spreading played a part in that. So you have a small number of people who could infect huge numbers of others in a very short period of time, but you've no idea who those people are. And actually, when we did risk models on this, so one of the parameters you put in is the viral load of the infected person. And yet the data we've got around, which came from the national data around swab tests, it varies by about 10 orders of magnitude. So you can just see that this number doesn't matter. Your ventilation moves over like 1 order of magnitude, and this number goes over like 10 orders. So you just see this totally dominates any calculations you do, and it becomes really challenging. And we probably know that that boundary's not that big, but we don't quite know how to narrow those down yet. So it's there's still a lot of work in there, but I think we've started to think about how you explore that in a lot more detail.
I guess you see a lot of the translation of what we've learned and how we started to talk about this then filtering into the more broader air quality conversation, because we have the same challenges framing risk when it comes to exposure to cooking pollutants or traffic pollutants, or as we were just talking about, our Bishak and exposure to mold spores and condensation damp and mold. It's going to be interesting to see how that journey translates now. I think we've found some ways of better articulating some of the complexities, and one of my favorite at the moment is that regardless of the nuance and complexities of the inputs, ultimately in most built environments, the levers that we have available to us to pull to affect an outcome often are only a handful, and that's background ventilation, local exhaust ventilation, source control, and administrative controls, knowledge and education and training, perhaps with the addition of air cleaners as well tacked on. But really, actually, as complex as all that stuff is, sometimes we're better off framing it from the perspective of the levers you can actually pull, the stuff that's within your control to affect an outcome. And that's where it goes back to your point about us not being very good at doing what we should be doing anyway, and that is providing adequate ventilation and decent local exhaust ventilation. We just got that right, we'd at least be able to park the ventilation bit. But I think the challenge of the pandemic was everybody very quickly realised we weren't really doing the basics very well, which meant it was just another layer of uncertainty into every built environment.
I mean, I think one of the challenges is, in a way, it's a little bit unfortunate, but that we had cost of living immediately after the sort of worst of the pandemic. So we're now trying to learn to live with a virus while people are going back to society at a point where everybody's now really concerned about their energy bills. So I think unfortunately, in a lot of places, people unlearned things far too fast because they prioritised shutting the windows and keeping the heat in. And that then really, again, goes back to exposing the fact that we don't have adequate environments, and the levers that we've got are really quite limited. I think there is a lot more we can do around helping people understand those levers in different spaces. And, there is a big education piece in there. Some of the projects we've worked on have looked at doing that. So a really nice example is from University of Sheffield, which Abigail Hathaway has done as part of a combination of a Protect study that we had and our Future Urban Ventilation Network and some other work that she did. It was with the City Council there, and they worked to look at ventilation in hospitality venues. So they were going in bars and restaurants and nightclubs and things, and put into both a combination of doing some measurement, but also to find out some of the barriers and the motivations around that. And there's all sorts of complexities now. If you're a nightclub, well, there are some weird things about atmosphere being part of it, being hot and sticky. But there's also some really practical things, like if they throw open all their doors, they tend not to have windows, but then they have issues with noise, and then they get shut down there. But that work ended up with some really practical guidance for environmental health officers that then, we've had huge engagement with that around providing that information to businesses. So there's some really nice ways in which we can show we can do it, but it takes time and effort, and we need to expand that all further into many more settings.
Yeah, and you can't.
I also want to wave a flag for maintenance here as well, because I think lots of people talk, well, we can't afford new ventilation, we can't afford to do this X, Y, Z, but we're rubbish at maintaining our buildings. We paint windows shut, we block things off, we tape over grills, we don't maintain HVAC systems, dampers don't work, etc. And it's basic, and we really should be waving the flag and saying, and perhaps this should be part of risk assessments in buildings. Perhaps this is something where people like the building safety regulator come in eventually, which is actually showing that you have done not just the basic minimum ventilation maintenance, but you have a proper plan for how you maintain your building, which includes ventilation, because you can't get away with it with gas, can you? You have to maintain combustion sources and heating and things like that.
Ireland's a good example of that. The Health and Safety Authority in Ireland have released the Code of Practice for Indoor Air Quality in the Workplace, and it's a fairly benign document on the face of it. It provides some very basic knowledge of what air quality is in the workplace. It talks about what adequate ventilation should be. It's nothing outside the bounds of CIBSE guidance or ASHRAE guidance for litres per second per person. But buried within that document is the very reasonable request that at least once every couple of years, you should provide evidence of the performance of the ventilation system in the workplace. Mm-hmm. The bombshell within that is nobody's ever looked at the ongoing performance of any ventilation in any workplace ever. That every single one of them has just been run to failure. You get air conditioning surveys that check the F-gas and do that, but nobody's gone in and measured if the meeting room is still delivering 10 litres a second per person. Yeah. And the hidden tripwire within that standard is now slowly those organisations, at some point, a health and safety inspector is going to be on that premises and will go, can I see your fire drill? Great, thanks. Can I see your ventilation assessment, please? And they'll go, your ventilation what now? And so that will bring that to the fore. And speaking to some colleagues in France about it, they've been looking at how you implement these ongoing monitoring of ventilation system in non-residential settings, and they've largely concluded that unless you catch it at new build, it's basically a waste of time. No ventilation system has ever been set up to be checked, and probably we're going to end up having to do it through low-cost monitoring, environmental monitoring, checking things like CO2 levels and things to try and get an idea of performance, because practically most ventilation systems have never been set up to be checked on an ongoing basis. And it just shows the value that we place or did place in ventilation. And hopefully that will change, would be my hope.
I hope so, yeah. And I mean, you touched on monitoring there. I think really that has to be one of the parts that play in this. And it's not straightforward, even that. It's very easy to put a CO2 monitor in somewhere and go, hey, look at these numbers. It's much harder if you say going to use that for some form of regulatory purposes, because you have to then think about specification of the monitor, specification of its location, how many times you're able to go over whatever limit it is for whatever reason, etc. Although, I mean, I say in Belgium, they've implemented it or are implementing it. So there is a move there. And I think, again, if we talk about positives that have come out, one of the changes that happened as a result of the pandemic was the UK building regulations were updated. They do explicitly in there highlight airborne transmission of infection. They explicitly state higher ventilation rates in certain spaces, including places, for example, like performance spaces where people might be singing or people might be more active. And they also do state the need for indoor air monitoring in certain places, I think offices particularly.
Yeah.
Now, you know, it's baby steps in some respects because, of course, that applies to new builds. But hopefully that does filter through into best practice as we go forward. I do think that retrofit is something that really needs to be looked at. And this was flagged. We did a lot of work with Royal Academy of Engineering on, we had this big piece of work called Infection Resilient Environments, which looked at, looked in the first phase, just looked at sort of in the middle of the pandemic about what was needed, but then had a sort of second phase which looked more strategically. And one of the big things that picked up was around, as well as sort of enforcement and compliance, was around retrofit, and how we make sure that we make sure that standards are there for retrofit and that we have the right things happening, and that ties into net zero policies, because I think there's a massive risk that people, in their rush to make buildings more sustainable, basically screw up the internal environment at the same time.
Yeah, for sure.
That's the technical way of saying it.
Yeah, I posted something on LinkedIn the other day with a house in a sealed airtight bag saying, in our rush to seal our homes from the cold, let's not forget we have to live in them also. And it blew up a bit. People going, that's a dangerous kind of picture to paint. But I went, well, it's kind of true. We do seal up these buildings from a environmental perspective, from an energy perspective, and we haven't in the past thought about ventilation very well. And the reality is, and we've seen it with the cost of living crisis, that nothing beats no ventilation for energy efficiency. People's instinct is to hunker down and close things off and shut stuff down and, keep the heat in. But there are unintended consequences of that,
Which I always say, my greenhouse is a really sustainable building. It uses no energy whatsoever. I pretty much hate to live in it for many reasons, though.
Yeah. And a lot of the work I do is with kind of strategy work with housing organizations. And one of the things they're having to get their heads around now is strategies around ongoing maintenance and budgeting, for rather than it just being a run to failure strategy for bathroom fans, that they actually now have a plan for the replacement and assessment of performance of systems. Because for the first time ever, it's another result of an emergency, the condensation damp and mold emergency as we see it at the moment following the death of our Bishak, is they're now going to have to stand over the performance of ventilation systems for the first time ever, rather than just, does it make a noise? Yes, we've got a bathroom fan. Now, for the first time, somebody's probably going to ask the question, is it delivering a whole house rate? Are we delivering flow rates in accordance with standards? Because the governance board of the housing association is being drawn across the coals now if it doesn't. So it's a very interesting dynamic to see shift from product specification, replacement like for likes, to actually specifying a performance and saying, right, what should this building actually have, and how do we make sure it delivers that, is a really big shift in focus. And I think that's another thing the pandemic has done, is shifted people to going, well, it's no good saying we've got a window. Is it doing enough? People want to know, yes or no.
Absolutely. There's a much bigger question in there, and it's a mindset shift as well. And I think, as well as, I mentioned maintenance, I think we should be thinking around installation, commissioning, and training for who does those. How do you make sure things are done right? Because an awful lot of things are set in stone wrong from the word go, not because the design was wrong or, because a wrong choice was made, but because it's not been implemented correctly.
Or it's just the perspective is slightly off, which means you don't get the outcome that you want.
You don't get the benefits.
Yeah. How did you find it as a domain expert or a sector expert being thrust into the center of an emergency in the way that you were? Because I kind of joked at the strange germ lady appearing at conferences, and I mean that in nicest possible terms. But you found yourself as a domain expert suddenly pivotal in pulling together, being the glue in the middle to a lot of these interdisciplinary perspectives. How did you find that personally? Because like you were right there front and center for a good couple of years, weren't you?
I was, yeah. It was a very weird experience. It was, yeah. It's a really hard one to say. Even now, I don't know if I fully processed the whole thing, and I don't know how long that takes to do. I mean, I was thrown in. I was properly thrown into it in April 2020 when I was asked to do a paper for SAGE, so the Scientific Advisory Group for Emergencies in the UK, and then asked to set up a subgroup of SAGE and to co-chair that subgroup. And that just it was a whirlwind after that. It was sort of, before that I'd actually been involved in some discussions with hospitals, and we'd done a little bit around, how do you repurpose spaces in hospitals, how do you look at the ventilation, think about oxygen, all sorts of things there. But this just like threw it straight in, and it was a real insight into the sort of scientific evidence requirements that are needed to inform an emergency. And I mean, it was incredibly hard work. We had an amazing group of people who we had. I mean, just to give you an idea of the timeline, I first got an email. I think it was the 7th of April. We were asked to put a paper together for the 14th of April, and the Easter weekend was between those two. So we pulled this paper together, myself and colleagues at Leeds, to just. And at that point, the evidence around COVID transmission was certainly what was in the public domain was really patchy. There were some very early studies in preprint out there, but just about everything else, we had to draw on what we knew about other respiratory diseases, SARS, influenza, etc., and what we knew about things like the physics of particles, ventilation. So, but we were thinking there not just about air and ventilation. We're thinking about the whole thing, including close range, larger droplets, as well as inhalation of smaller aerosols. Thinking about surfaces and contamination, and really at that stage, we couldn't take anything off the table because you knew that there was a massive gap in the evidence. So trying to think about anything possible. And then, of course, we then created a group within another week and published another paper within a week after that. So it was just a phenomenal amount of work with an amazing group of people in a very short period of time.
And for context, I mean, so April, like going into Easter, I mean, that we were in the height of the slide into lockdown at that point. I mean, I remember
we were in lockdown. So we went into lockdown here on the 23rd of March. So this was, and a lot of the questions at that point from policymakers were starting to think about, well, what understanding transmission in the environment because of what do we need to put in place for when people do start to come out of lockdown.
Were you already starting to think about that at that point? Because my memory of the kind of the March-April period was everybody had Italy in their foremind about how bad could this get, and it was this flattening the curve, trying to just slow everything down so that we can find a level that the systems can cope. And different jurisdictions had different stressors because of what their own capabilities. So Ireland had almost no ICU beds. So our panic to flatten the curve was out of pure necessity. We were running out of beds really fast. So there was that going on. But you were saying even then you were starting to say, right, okay, because like this is unsustainable, complete lockdown for more than a few weeks. What does the trajectory look like out the other side?
Yeah, so there are people who were, I mean, I wasn't directly looking at that, but there were people who were looking at what the trajectory might look like. And then, you know, looking at that practicality of, well, both when you come out of a lockdown, but also not everybody could lock down. The people who had to carry on working, had to carry on interacting. How do you enable those environments to be safe? So one of the role, I guess, the biggest role we played there was around the evidence base. Questions from policymakers around what we know and what we don't know about different mitigation measures, about transmission, etc. And of course, it's an emerging evidence base. It's a hard one to put together. There's a massive set of uncertainty in there, and I think there was a bit of a feeling at the beginning. I think we always just you sort of almost just jump in and try not to think about it too hard. But over time, there was that growing awareness that there was a big responsibility, because the things that you said scientifically, where you had evidence and where you didn't have evidence, then played out into policy. So, to be absolutely clear, we never made policy. That's the decision of that's for the politicians to do. That's way above my grade. But you're aware that the evidence that you provide has an impact on those decisions, and therefore there is quite a big responsibility to think, well, have we got this right? Have we got this as right as we can? And there may have been times, I think, when you've got some gut instincts and things, but you can't write evidence on gut instinct. You have to write down what is known and where the uncertainties are, and that then plays into it. So, I mean, I think the other thing I found with all of that process was I interacted with a heck of a lot of different scientists and different disciplines. So, particularly mathematical modelers, epidemiologists, behavioural scientists, etc., as well as the people I am more familiar with in the sort of building science, the environmental, microbiology type spaces. And I learned an awful lot from some of those other disciplines. I think I became a better scientist because of it, because I think it made me think more about uncertainties, evidence, and the knock-on complexities. And I think the people I probably gained the most from was behavioural scientists, because I think as an engineer, it's very tempting to go, oh yeah, technology, oh yeah, this, and we do another CFD model, and hey, look, we've modelled what happens, but we know that doesn't happen. Just doesn't happen in reality, because there's people in the mix, and buildings would perform so much better if they didn't have people in them.
Yeah, wouldn't our life be easier? Yeah, I mean,
our life would be so much easier, but we have to think about what people do. We have to think what their motivations are for different things. And they don't always do what you think they should be doing. They do all sorts of weird things.
Yeah, I was saying to somebody the other day, if I had my time again, I'd love to have done more social science in my life.
Yeah.
I think that is so fascinating and so underrated for outcomes.
That and a bit of biology, I think.
Yeah, for sure. I mean, my recollection of the time as well, although we were a bit later to the party with the ventilation group in Ireland, was just the overwhelming amount of evidence you had to read, documents you had to read to try to be able to have an opinion. Both standards were coming out left, right, and centre from SIBSI and ASHRAE and REVA, and loads of engineering advice. You had loads of advice on epidemiological advice coming through and scientific advice coming through. Were you involved in that odd clash between disciplines of what was meant by airborne and what were the implications of calling something airborne? Because I think that was one of for me, the greatest examples of how language, even between disciplines, can have completely different meaning and completely different implications out the other side of it, that can become a real sticking point and a really slow action down. Because you haven't developed a common language beforehand to be able to navigate a scenario like that. And that airborne one was a biggie, wasn't it?
It was a massive one, that one. And yes, to some extent, I was involved in that. Because I was involved with we called the Group of 36. So that Lydia Morawska that
Yeah.
led, and, writing a letter that said we need to recognise airborne transmission, and really trying to bring that evidence to the fore. And I think, from day one of the activities that I was involved in, airborne transmission was on the table. But it almost had to come from a position of, well, at the moment we're washing hands and doing surfaces. I couldn't just pivot to everything being airborne. And I don't think that's right either, because I don't personally think we can dismiss hands and surfaces. I think a lot of the time they play no part, but there are some environments where we touch a lot of stuff. And, it's not just thinking about the aerosol and droplets from your mouth that land on something. If you're ill and you've got COVID, you cough in your hand and you wipe your nose, and you end up with contaminated hands. And you can see that in some of the data. You can see where you see contamination in environments. Some of it is the surfaces immediately around, which is deposition, but some of it is like handles and things, which is clearly from somebody's contaminated hands.
Yeah.
But I think, I mean, if you think right back, we had suspicions around different modes of transmission. I think we fairly quickly, probably right from the beginning, knew that when you're close to somebody, you're going to inhale it. We can debate whether that's what size of particle that is that's involved, but you're going to inhale it. I think evidence around longer range airborne transmission, so, the other side of the room or in a room next door or whatever, that evidence was a lot more patchy. And what we started to see in the first few months was you saw these super spreader outbreaks that it was very hard to explain in any other way.
Yes. There was a good study out there a few weeks back from Germany where they had good control cases of classrooms with filters and not with filters. It became a bit contentious actually online, but there wasn't any clear evidence of any benefit from the filters in the end, because they just couldn't be sure whether the kids were catching it outside of the classroom environment ultimately. So even when it was airborne, it's very difficult to create a straight line between an outcome of something being airborne and that's where you happen to catch it. Because unless you can measure it in that environment, which, as you said at the beginning, was being one of the big challenges with COVID, it's been very difficult to prove those straight lines.
And I think this is where it became a challenge, in that, to start with, those were being dismissed. People were saying, but what about X? What about Y? I think over time that Gov recognised that it was important. But even now, the extent to which a ventilation measure will reduce transmission is uncertain. I think we know it does. I mean, we've run a study in schools in Bradford in the UK where we've had air cleaners in classrooms, and we do see a reduction in illness absences in those classrooms. But I don't know that would play out absolutely everywhere. And, again, imagine, I'm not sure, was the one in Germany, was that an early years setting with their younger kids?
Yeah.
I can't remember. Yeah. So early years setting, well, kids interact very closely.
All over each other. Yeah.
And maybe that actually, you can have as good a ventilation you like, but if they're transmitting at very close range, you might just never see the effect of the ventilation because something else has just completely swamped your risks.
It's a bit like risk mitigation in a nightclub. If people are sucking the faces off each other, there's not much ventilation's going to do about that.
Precisely. Yes. Yeah.